Good evening. Thanks everybody for coming out. My name is Tim McKee. I'm the Emergency Management Coordinator and 911 Director for Chippewa County. We always bring up the National Weather Service to do their presentation. Tonight we have Jim Kaiser and Mike Bogath from the Gaylord Office of the National Weather Service here to give us their predictions. How's that?
Yeah.
There's coffee and cookies over here too, though.
We're beating it to the punch here.
We're not having any cookies yet. We're just having coffee, but if you start eating cookies, we may join in. So.
Well, first of all, before we get started, I got to thank Mr. Tim McKee, your emergency manager. He's almost solely responsible for making Chippewa County the only storm-ready county in Upper Michigan. There's a lot of work to do that. And me and Jim were talking, we were wishing all our emergency managers were like Tim. Tremendous guy to work with, and thanks for helping put this together. And thanks for everyone here for showing up on such a beautiful spring day. We really appreciate it. I know there's a lot of gardening to attend to and whatnot, but hey, those days, believe it or not, are coming. Right now, spring's in like Texas and Mexico, but it'll get here eventually. It had highs in the 80s and 90s yesterday, so it's building north, and there's some severe weather out in the plains to show that it's actually on its way. Unfortunately, before we actually get there, we might deal with a little wintry mess for this upcoming late week into the weekend, but it's something to keep an eye on. Anyways, we're here to talk about spring weather and more specifically severe thunderstorms. The season is approaching. We live in a pretty safe area here in northern Michigan, but that's not to say that we do not get severe weather. My name is Mike Bogath. I am a meteorologist at the National Weather Service in Gaylord. And Jim Kaiser is our warning coordination meteorologist, and he helps put all this presentation together. So, at any time, please feel free to raise your hand. Very informal. The first part is going to be loaded with science, but if you have any questions at all, feel free to raise your hand, and I'll do my best, or Jim will do his best to answer.
Sure.
Before we get started, Jim here has a spotter book. We're going to pass around. It has a pen in it. There's a paper already started with a list of names. Just continue on that list. Basically, your name and email address. And what we're going to do now, from this point on, with these big severe weather events, we're going to shoot out a mass email to the spotters that sign up, saying, hey, something's coming, and we'd like to solicit reports if you get anything. So you don't have to sign up, but we'd appreciate it if you did.
Yep.
So let's get started. First of all, this video scene here is a compilation, or whatever the word you want to call it, for a bunch of videos that were taken across the country dealing with severe weather moving in. These are shelf clouds more specifically, and we're going to show you a little demonstration of shelf clouds a little bit later. Once again, thank you, Tim, and thanks for everyone for showing up. The agenda, the intro, and the attendance book that's being passed around. And then we start getting right into the science. Thunderstorms and tornado development, like I said, can be pretty technical. At any point, feel free to raise your hand, please. Hazards associated with thunderstorms. Besides tornadoes, which get all the press, there's lightning, hail, flooding, and strong and gusty winds that can produce damage without having tornadoes. Rip currents and water spouts. Most people think of rip currents as an ocean phenomenon out in the Pacific or Atlantic. The state of Michigan averages about 10 rip current fatalities per year because of the rip currents that happen in the Great Lakes. And one of the more deadly locations is right there on US 2, going west out of St. Ignace, some of the more beautiful beaches probably in the whole area. Right there is a pretty deadly rip current spot, right off Mackinac County. Water spouts, anyone ever seen water spouts? I would love to see one. They're pretty common in the fall and early winter. In northern Michigan, those are what we call non-tornadic water spouts. But you can also have tornadic water spouts, which is nothing more than a tornado forming here and going over Lake Superior. We'll have a quick break, and then we'll talk about the most important part of the talk, the importance of spotters, why you're so important to us, how you help us do our job and succeed in our job. And we'll deal with watches and warnings. That's the question we get asked every year. A new style of warning we're going to start. It has started already. We have not issued any yet. This is brand new, these impact-based warnings. And finally, how to contact us and complete a spotter report. I am not responsible for any of the humor you see here. If you don't laugh, blame Mr. Jim Kaiser. Because
It
you put
is
this.
hard to find weather humor. It's hard to find non-copyrighted free weather humor on
That's the
YouTube.
key, free.
That is difficult to come across.
The government is in a little budget crisis, so we got to do everything free. Okay, here we go. A little bit of science like I described, and like I said, at any point, please raise your hand, and I'll do my best, or Jim will do his best to help answer the question. Thunderstorms. Thunderstorms are nothing more than gigantic heat engines. They need a lot of heat, and they need a lot of moisture. Got to have both to get thunderstorms. Not surprisingly, where do you think most of the thunderstorms are? This is thunderstorms day per year. This is how many days per year at least one thunderstorm was reported. Down south. Hot, humid. This season's already started. It's already kicking in. They're reaching their peak of their severe weather season right now in the plains. Farther north, colder, getting up towards Canada. You're farther removed from the moisture, less thunderstorms. Well, you could argue we're surrounded by Great Lakes, the most beautiful waters in the world, right here. Plenty of water for thunderstorms. The lakes actually suppress thunderstorm development in the spring and summer. Why? Thunderstorms need a lot of heat, okay? A lot of moisture. Jump at Lake Superior in June or July when it's 65 or 70 degrees out, the lake's not even close to being that warm. Water takes a tremendous amount of time to warm up. This is like a heat sink, keeps everything cold. Cold air is dense, wants to hug the ground. You need warm air to rise to produce thunderstorms. So the lakes actually suppress the thunderstorms. Many times, and Jim can attest to this, we'll be watching severe weather over Wisconsin, they'll be getting pounded. Hits Lake Superior or Lake Michigan, and they quickly decay as they hit that colder water. Now these lakes just do the opposite effect in the winter. They supply a lot of snow, lake effect snow, because they stay warmer. Now they're the source of that warm air, but just the opposite in the spring and summer. To get any type of precipitation, you need two key mechanisms. Lift, a way to lift the air, and you got to have moisture. You can lift air all day. If there's no moisture present, you're not going to get any precipitation. So lift and moisture produces your rain and snow. How do you get lift? Several ways. Fronts. Nothing more than a cold and warm front you see any day on the local media weather report. Lake breezes. Very common here. May, early June, it's warming up. Nice warm start to the day. You think it's going to be pretty hot today. Then the winds come out of the northwest, right off Whitefish Bay and Lake Superior. Temperature drops 10 or 15 degrees. That's that lake breeze. Because why? The lakes are cold. Cold air wants to stay on the ground. It wants to spread out. It's like a little cold front sweeping in from the cold waters. And old boundaries are nothing more than thunderstorms that maybe occurred the previous evening. They've rained themselves out, but that rain-cooled air kind of hugs the ground, and the next day, that's a source of new storm generation. Instability can be a little technical to explain. Imagine a hot air balloon is a great example. How does a hot air balloon work? You heat the air, hot air wants to do what? Go up, it's less dense. That's instability. The air gets hot next to the ground, the sun comes out, heats the ground, that air becomes less dense, more buoyant, wants to float, it goes up. And depending on how cold it is above you, and the temperature difference between the land and the warm air at the surface and the cold air above, determines how unstable it is. The more unstable, the more the air wants to rise. Air rises, by the law of nature, it has to cool. It cools at a certain rate. But as long as it stays warmer than the surrounding air around it, it'll keep rising. That's an unstable atmosphere. Stability is just the opposite. When it's stable, the air goes up, the air is then colder than the air around it, and it wants to sink back down. So to get thunderstorms, you want an unstable air. You want the air that wants to rise and keep rising. We talked about fronts. A cold front, probably the most common source of severe weather in the Great Lakes, is nothing more than a snowplow. Cold air wants to hug the ground. So this area out here has been heating up all day from the sunshine, getting warm. Here comes your cold front or your lake breeze, comes in, hits this warm air that already wants to rise because it's warming up. And then the cold front comes in and gets a little extra kick. One of our busiest areas for thunderstorms is just south of here, right in central, right on the border of Mackinac and Chippewa County. Two colliding lake breezes, Lake Michigan, Lake Huron, and then sometimes Lake Superior, actually three. They all connect in there. All that forces that air upward. Air can't go into the ground, it's forced upward. So a lot of times, I remember when I lived here, I could look off to the south and see these beautiful thunderstorm heads. And that's that colliding lake breezes from Michigan, Huron, and Superior that come in, they come together, and the air between them is forced to go up. Here's your typical garden variety thunderstorm. My grandmother used to call them toad stranglers. They'd come up and they would pour rain for 10 or 15 minutes, rain like crazy, and then they would rain themselves out. This is what you see in Florida every day. You can set your watch by these things in Florida. 1 o'clock, 2 o'clock, you see these all over. Sun comes out in the morning, heats the ground. Hot air wants to what? Go up. Starts warming. If you're unstable up here, the air keeps rising and rising. As it rises, it cools. The moisture in it that you don't see, water vapor, condenses to form cloud droplets. At this stage, the beginning stage, the towering cumulus stage, it's all being supplied by your engine. All heat. Heat and moisture going up, cooling, forming the cloud. Precipitation's forming, but your updraft is keeping that precipitation suspended. Nothing's reaching the ground. You see these bubbly cotton ball clouds. Eventually, the cloud grows high enough, sometimes 40, 50, 60,000 feet in height. You got a whole bunch of precipitation up here. Got to remember, up here in the middle of summer, it doesn't even know seasons exist. It's bitter cold, so up here you got snow, hail, ice balls, rain, all mixed together. You're getting a lot of weight. Some of that starts to fall. As it falls, it brings all the air down with it, got a lot of momentum, and now you got the precipitation core and your downdraft, blowing that cold air to the ground. That's that cold air you feel when the storm moves in. That's the air that was above you, all that rain falling. So in the mature stage, you have your updraft feeding the storm, your downdraft supplying the precipitation. This is where you're going to get severe weather. A lot of lightning, maybe some hail and strong winds. Eventually, in a typical Florida type thunderstorm, your downdraft comes down, hits the ground, and it spreads out in all directions. Eventually it comes under, cuts off your updraft. Now your storm is no longer being fed, you've taken the food away, it's all downdraft dominated, and it rains itself out. From here to here, 45 minutes to an hour. This, mature stage, 20 minutes. However, we're interested in what produces severe weather. Those can produce some really short-lived severe weather, some marginal hail, some relatively weak, short-lived gusty winds. But to get to those really big severe weather threats that you see on the news and every so often we experience up here, it's not those garden variety thunderstorms. It's long-lived thunderstorms produced by wind shear. And wind shear can be pretty technical to explain. It's nothing more than change of speed and direction with wind with height. Okay, you can have winds here from the south, it's warm, it's getting hot, nice southerly breeze. Those winds don't have to be from the south above your head, and usually they're not. As you go up, they start to veer. You go up a little bit in their southwest winds, you get higher up in their west, and they get higher up their northwest. And a lot of times winds up here are blowing 60, 70, 80, 100 miles an hour. You have a lot of spin there, horizontal spin. You can see it here demonstrating this picture. You can't see it spinning, it's air, but it's spinning. It's there, and that can create a tilted updraft. Here's an example in real time, or a real picture of wind shear. Southeast winds at the surface. As you go up to 5,000 feet, you can see the speeds are increasing and they're veering with height. Southwest, west, northwest. This is creating that horizontal spin that can tilt an updraft, keeping the updraft and downdraft separated. And simply put, the longer the updraft and downdraft stay separated, the longer the storm can live, the greater the chances for severe weather. You can see here in this diagram, change in wind speed or direction with height causes the thunderstorm to become tilted because of that wind shear throughout the layer. And this allows the storm, as it becomes tilted, the downdraft falls farther back, and your updraft is out in front of the storm. Now you got a longer feed of air. This downdraft never cuts off the updraft, or it takes a much longer time for that to occur. The longer the storm can be mature, the greater the threat to generate large hail, the greater the threat to generate a very strong downdraft and gusty winds along the leading edge of that downdraft. These tilted storms can go on for hours, 4, 5, 6 hours. Not that garden variety that I showed you last from 30 minutes to 45 minutes. Here's a typical radar example of those long-lived storms that can congeal together to form these squall lines. This is our typical severe weather event for northern Michigan. Not the tornadoes you see out in the plains, not those storm chasers that you see on the TV that have like a mile wide tornado on the ground. That's extremely rare. This is much more typical for our severe weather threat. These can do a lot of damage. One thing, they're a lot bigger than tornadoes. You can have wind damage all that way, the whole line, from Sault Ste. Marie all the way down to our southern areas. So like I said, these can be long-lived. You can see it crosses almost the entire northern lower peninsula and eastern upper. It can produce wind damage. And you can see that here. This is actual from that event. This happened in Traverse City. That was 2005. And this wind damage can last for a long time. That's why tornadoes get all the news. That's what you hear. These can be just as bad and create a larger damage area because they're so extensive. So these type of thunderstorm complexes, squall lines we just showed you, do a majority of severe weather damage in northern Michigan. Mostly gusty winds. There are some hail types, sometimes large hail associated with these, but the main threat with these squall lines is extreme wind gusts along the leading edge of that heavy rain core. The intro slides that we were showing you, that little movie, was the shelf cloud along the leading edge of that heavy rain core. That's that wind gust that's going to hit you. Storms continually reform at the front of the thunderstorm complex. Everything's tilted. Your downdraft's farther behind the storm, but part of that downdraft cuts out down beneath the storm and acts like that plow, like that cold front, like that lake breeze. It's hugging the ground. It's cold. All the air out in front of it is untapped. It's been heated from the sun. So now you have a continuous plow just taking that warm air and forcing it up into the cloud and feeding it. Such for the long-lived nature of these events. And then a fancy name that we give to the ones that make the record books, the ones that are prolific wind producers, it can cut across several states, are called derechos. Pretty rare. We had a really bad event this past summer just south of Michigan in the northern Ohio Valley. A cluster of storms started in Iowa, which we're going to show you, and made it all the way to the east coast, doing extensive wind damage along the way. And those are known as derechos. We in Michigan are due for something like this. They average once every couple years. It's been many years since we've seen one, and one of the worst ones we've ever seen in Michigan started as a cluster of supercell thunderstorms, which we're going to talk about, out in the plains. One of them responsible for wiping the town of Spencer, South Dakota, right off the map with I believe, an EF4 tornado. Those supercells, individual storms, gathered together along their gust fronts, their cold air outflow, produced a squall line that went up into Canada, cut south across Lake Superior. It did wind damage from upper Michigan all the way to the northern Ohio Valley before dissipating later the next day. That's your derecho, long-lived, prolific wind producers. And here's your example of last year. Kind of some individual storms start to group together. Once they get in this configuration, the wind's coming in right behind them, and now they are just plowing along. These are individual warnings that the weather offices were putting out along their track. A couple tornado warnings, but mainly severe thunderstorm warnings. And these winds here were gusting at times to over 100 miles an hour along that whole line. Okay, a tornado's 100 yards wide, 50 yards wide. Look at this. This is cutting across the whole state of West Virginia, producing wind damage. Eventually, later in the day, you can see here it's almost 9 o'clock, 10 o'clock. It's losing the heat from the sun. The sun's gone down, and now it's going to run into some cooler Atlantic air, and it starts to dissipate. But wind damage went all the way across several states in a multi-million-dollar event. Signature cloud lines for signature clouds for squall lines is that shelf cloud. That opening movie we showed you were all a bunch of shelf clouds. That is along the leading edge of this cold air. The storm's tilted. You got your wind shear. Downdraft's coming down. Part of it's spreading out. Untapped air, a mini cold front. Cold air wants to sit on the ground. Can't go up. So it's acting like that snow plow going down the road. As it plows out ahead, the storm's moving from left to right. So you're over here. You see this low hanging cloud coming. It can look really menacing. Sometimes it can be rolling horizontally. They're called roll clouds. Shelf clouds, roll clouds, pretty similar. That is that leading edge of that cold air, the warm air that you're at. So the storm's coming at you, you're in the warm air is feeding up into the storm, going over the mini cold front on the ground. and you can see this cloud spinning horizontally as the air goes up and over into the cloud. That's that shelf cloud. Really low, real menacing. Behind the shelf cloud can look really dark and great, but it's usually a nice flat color, and there'll be a lot of lightning. That's your heavy rain and hail. But when that shelf cloud gets over your head, you're going to get a lot of wind, and we're going to have a video here to show you that. Here's one from our office back on Memorial Day. This is looking southwest from our office. The thunderstorm complex, you can see this nice gray, kind of darkish color, nice smooth. That's your heavy rain. There was no hail with this particular storm, but there's that cold air. So over here, the storm's coming at you here, and we're here at the office. The warm air untapped, still unstable, going up and over, feeding the storm. Your downdraft's back here where all your precipitation is. The leading edge of that downdraft is this shelf cloud. And once that gets to your head, over you, the winds pick up, and just behind that, you get the heavy rain and possibly hail. Now, we talked about those long-lived wind events along squall lines. They can be really miles and miles long. Now, embedded in that can be localized areas of much stronger winds, called downbursts. I'll play that again. This mass is nothing more than a ball of rain and hail falling from the cloud. A bowling ball dropping out of the sky. Has a lot of weight, a lot of momentum. It hits the ground, all that momentum can't go into the ground. It spreads out, and right along the leading edge of that ball, you can make it out barely right here, can be some extreme winds. So you already have gusty winds with the shelf cloud and the downdraft, but now you're getting these localized bursts from these bowling balls of precipitation that are bringing additional momentum with them. And that can enhance the winds by several miles per hour. So a lot of times when we're doing storm surveys, we'll be out and we'll find a bunch of areas of just general damage and then enhanced damage, not produced by tornadoes, but produced by these downbursts, these enhanced wind speeds from these bowling balls of precip or some evaporational cooling, which I'll describe coming up, that are enhancing the wind flow. How a downburst develops, there's really two ways. The more common way, think about these clouds. Okay, they're not brick walls. Air can go in between them and whatnot, and some of that air around it can be pretty dry. What happens when you get out of a shower? Pretty cold, right? Well, two reasons. You're in a nice warm shower, but also you come out of the shower, there's evaporation taking place. Evaporation is a cooling process. It's got to take some of the air, the energy from the air to break the water molecules up. It's a cooling process. Cold air wants to do what? Go down. So up here, you get dry air into the cloud, got all this precipitation up there. It evaporates because of the dry air. It gets cold. Now you got a bunch of cold air momentum, and it wants to come down fast. The other way the downburst happens is your updraft comes in feeding the storm. It gets cut off for some reason. Maybe that downdraft finally catches up to it, cuts off your supply, and now this updraft that's been keeping a lot of your rain and hail up here is gone. It can no longer hold it up. And that's where you get that. That's just a bunch of rain and hail being all released at the same time. Like I said, it can produce prolific but localized extreme winds. Here's a downburst on radar, Doppler radar. Here, the Doppler effect, you listen to a train whistle, the train's coming at you, it has one sound, and once it passes your spot, it changes pitch. That's kind of like the Doppler effect. And we can do that through the clouds. We can look at the way precipitation is moving to and from the radar. In this example, the Sioux Falls radar is right up here. Anything green colored is precipitation blowing towards your radar. So all this green is blowing towards the radar. The precipitation in the clouds, we can see it coming towards the radar. Anything red is blowing away. Doesn't help when you're red-green colorblind like myself, but I got people like Jim to help me out there. But you can see there's really close couplets. Green and red just touching, not spinning. They're connected extremely close, blowing in opposite directions. Here, there's one here, I think, and there's one here, where these arrows are, I'm guessing. And because of that, that's that downburst hitting the ground, and you're seeing the wind go up in two different directions, side by side. Those are localized, enhanced areas of wind. There might be tremendous wind along this whole area. Okay? This is part of your outflow boundary right here. That's your cold air. but embedded in the precipitation core. So here's your cold air shelf cloud producing damaging winds. But just behind that in the precipitation shield, you have these bowling balls of mass, heavy rain that are coming down and producing localized, much stronger wind fields. Here's an example. I believe this is Indiana. Okay, that's not a tornado.
Wow.
Does as much or more damage than most tornadoes. Yes, sir.
What's the duration of that, low to high? How long does it last on?
Oh, it can vary. A lot of times, these winds can go from nothing to 70 or 80 miles per hour, and they don't usually last very long, a couple minutes at most, a lot of times less than that. But you can see what they can do. I don't know if you noticed, with that gigantic tree, it toppled over, and you can see some of the shingles being ripped off the house. And these localized enhanced wind fields, these downbursts, can produce, like I said, prolific wind damage in pretty small areas, embedded within a larger area of damage from the downdraft of the storm itself. High wind safety, simply put, you want to put as many walls between you and the outside environment as possible. The more walls, the better. The best place, of course, if you have one, is in your basement. Okay, if you go into a basement though, don't just go in the middle of the basement and look up and say, wow. Get under a workbench, something sturdy. If you don't have a basement, small interior room, small closet, hallway closet, bathrooms. Bathrooms get added reinforcement because of all the plumbing. There's been several cases where houses have been knocked down, but you look and the bathroom's still standing because of the plumbing in the walls. But hey, don't just get in the bathroom, get in the bathtub. If you have time, put a blanket over you, something to protect you. As many things between you and the outside as possible. Don't waste time opening your windows. Back in the day with tornadoes, they used to say, you know what? The pressure difference knocks down the house. It ain't the pressure difference at all. It's the winds of 150 miles an hour that are knocking down your house. The time you waste opening your windows could be the time you could have to save your life and find better shelter. So don't waste time opening windows. Get away from windows. Get out everything mobile and seek shelter inside. And if caught outside, lie flat in a ditch and cover your head. But what do thunderstorms bring with them? A lot of what? Water. And where does water go? What are ditches designed for? It's to hold water. So, don't drown.
Snorkel.
Yeah. And there's some local wind damage out there in Manistee. We didn't have a whole lot the last several years, but there's a little bit. And that's your typical, that's what we see a lot of, these localized areas of relatively minor wind damage. Okay, now this is the one that gets all the press. This is the one when you turn on the Weather Channel tonight, you're going to see storm chasers chasing in the plains tonight. There's going to be several of these tonight out in the plains. They're already out there right now. There were several last night that were producing tornadoes. These are your supercells. These kind of have a life of their own. They're individual storms, not part of a big line of storms. When you look at a radar of a supercell, it's just one blob. All by itself. It has all the air around it to work with, all this heat. There's no other storms to bother it. It's got all the heat it wants. There's no other storms next to it sucking up other heat. It's by itself and it's spinning because of that wind shear. Supercell here is moving from left to right across your screen. Unlike the other storms where the energy or the updraft supplied ahead of the storm, these come in from southwest of the storm. They're up feeding it. All this up here, the storm's going like this. It's got all this untapped, nice warm air that's just blowing right up into it, feeding the storm, up at an angle. It's producing this downdraft and heavy rain and hail. Did you ever hear when they interview people that have been in tornadoes, a lot of them say, it got quiet. Got quiet, and then the freight train was coming. A lot of truth to that. What happens is you get hit twice with the supercell. You count here comes a storm, you get hit by the burst of wind with the downdraft. That might produce damage. Then you move under the heavy rain. Your updraft is here. Now remember, your updraft is going to suspend precipitation up in the cloud. It's blowing up here sometimes 100 miles an hour, straight up, or at a little angle. So here you go, you're in rain, you're getting closer to your updraft. The rain starts turning to hail. As you get under or even closer to the updraft, it's got gigantic hail that's keeping up here. So you go from rain to small hail to big hail. Then you stop, you need nothing. Precipitation stops. Why? Because now you're right under the updraft. Now it's keeping everything above your head. But guess what comes along with your updraft? Your tornado. There's a lot of truth that it got quiet in the freight train. You might have been in heavy rain and hail, and all of a sudden it just gets nice and quiet. You're under your updraft, and soon it follows the tornado. Now less than 1%, much less than 1% of all supercells produce tornadoes. So tornadoes by themselves are extremely rare. Thank goodness for that. There's a lot more supercells than there are tornadoes. But these supercells are spinning like a top. Supercell thunderstorms are much less common across northern Michigan. They need a lot of heat, they need a lot of humidity. Something we usually don't get a good combination of. They need a lot of wind energy. They need everything to come together just perfect. Where's the hot spot? I'll show you here. The plains, the corn belts. They are defined by rotating column of rising air, or updrafts. Whole cloud is spinning like a top. Now I mentioned that supercells aren't very common in northern Michigan. They do happen. What year was that? 2007, Jim?
Yep.
October? 6 tornadoes?
6 tornadoes.
6 tornadoes in October 2007, all associated with supercells. They were much smaller in scale than the ones you see in the plains, but we had 6 tornadoes in a matter of a couple hours. Easily, I think, the busiest night we've ever seen severe weather-wise. Much more rare they're here. And when they do produce tornadoes, they're usually not your gigantic F4s and F5s, but you know, it can happen. And these can produce significant severe weather, including tornadoes. You get the rain with them, you get the heavy winds, the large hail, and then you get the tornadoes. You get them all with this. Here's a cross-section of a supercell and important cloud features. Storms going from left to right across your screen. Updrafts coming in behind the storm, feeding all the hot air, untapped down here, nice and hot, a lot of humidity. Going up at an angle because of your wind shear. So right here, rain-free brace. Why? The updraft's right over your head. Keeping everything, shooting everything out at an angle. Shooting it right up here. Hail, heavy rain being ejected, coming down your downdraft. And over here's your shelf cloud as you get the leading edge of the cold air with the rain core. Strong winds, heavy rain, hail, lots of lightning, cold, tornado. That flanking line is just additional storms that develop. So a lot of times you get one supercell pop up, it dies, soon they're replaced by another one. And they can look continuous on radar because as this one dying, this one's taking over. They can go on for a long time because of that. Here's an aerial shot from like an airplane. Like I said, you know, this is a still picture, but this whole cloud slowly rotating. Anvil, that's that really high level cloud feature. Remember I said about instability? Up here is the stratosphere. Ozone. Ozone likes to warm up. Up here, temperatures increase with height. Down here where we live, as you go up, it gets colder. Not here, not in the stratosphere, it's just the opposite. Your updraft comes up, hits the stratosphere, now it's stable. It's always stable up here. There's your lid. That's putting the lid on the pot of boiling water. Updraft comes up, hits the lid, it spreads out, and you get this anvil. It's spreading along that lid. However, sometimes your updraft is simply so strong it'll temporarily break that lid. You get some of these we call overshooting tops above the anvil. That's just indicative of a very strong updraft. The stronger the updraft, the larger the hail, the greater the chance to load precipitation, the greater the chance for strong winds at the surface, the greater the chance of a severe storm. Backsheared anvil, the winds here are going from left to right. You can see the storm movement. But the updraft is simply so strong, some of that's being ejected against the prevailing winds. And up here, winds can be blowing 100 miles an hour. Another sign that your updraft is extremely strong. Here's what it looks like from the ground. Like I said, it's hard to show here. It's a still photograph. In real time, this will be rotating. Left to right across your screen, the storm's moving. Rain area, hail area, rain-free brace. Why? What's right here? What's blowing up here?
Updraft.
The updraft, keeping everything suspended and ejecting everything out in front of it. Wall cloud. When you look at this in real time, it'll be spinning. Not super fast. It'll be spinning. People love it. You can see it when they record it on like a videotape, they play it fast forward, you can really see it then. There's going to be a tornado, it's dropping right out of the base of that wall cloud. Like I said, less than 1% of supercells produce tornadoes. It takes a lot of special ingredients to get a tornado to form. Look at your tornado hotspots. Kind of co-located with your better thunderstorms. Little Max in Florida. Look at the plains. Tornado belt. We've all heard about this. This is where the big ones are. Oklahoma, Texas, Kansas, Nebraska. However, look at Southwest Michigan, Indiana, Illinois. Little second max. What do thunderstorms need a lot of? A lot of heat and what else? Moisture. In the spring and summer, what do they grow down here? Corn. Lots of corn. Corn belt. An acre of corn releases a tremendous amount of water. I don't think the numbers are. When I heard of, I couldn't even believe how much water an acre of corn releases. You had a lot more fuel. So you got your second tornado area, clip Southwest Michigan. Northern Michigan, less than 1. UP, hardly any. It's pretty rare to get a tornado in Michigan. We had one in Gladstone in 1992. We had a few others, but it's pretty rare to get tornadoes in the UP because you're surrounded by the cold waters and you're simply farther north from all your heat and humidity. Michigan averages, I think, about 16 to 17 per year, most of those across southern Michigan. So how do tornadoes typically develop? They develop normally with supercells. The whole air is rotating. Wind shear. I'll explain it here in a second. I think there's a nice little video on that. That's at speed and direction changed with height. Tornadoes, though, they like a special wind shear. Okay, supercells and other thunderstorms, they like a lot of that deep wind shear. Got to go from top to bottom, way up. To get a tornado in supercells, you get a lot of that low level. We want a lot of spinning with the winds or turning with the winds right near the surface. The first 1,000 feet. Kind of tightens everything up. So you get a lot of wind shear at the lowest levels. This horizontal rotation is tilted to the vertical by a strong updraft. Think about a figure skater. Got a lot of spin in the low levels. Think of a figure skater. Him or her got her arms out. They're going around. What happens when they bring their arms in?
Faster.
They go faster. There's your tornado. Everything at the bottom. Everything's tightening up, rotating faster. That's what your rotation's being tilted. As it tilts, it starts to tighten. The figure skater bringing his or her hands in. And they're stretched out and narrowed, and that accelerates the figure skater. Think about that. Here's a little video.
Storms with strongly rotating updrafts, also known as supercells, develop when the wind veers or turns in a clockwise direction through the lowest mile of the atmosphere. When the wind speed is sufficiently strong and veering with height is present, horizontally oriented rolls develop in the lower levels of the atmosphere. When these rolls are tilted by a thunderstorm updraft into rotation about a vertical axis, a mesocyclone may develop. A mesocyclone is defined as an area of deep storm scale rotation, usually associated with a strong updraft. The area near a mesocyclone is the preferred region for severe weather. Rotation can increase updraft and downdraft velocities significantly.
Wind shear. A lot in the low levels. Think about your hands. Put a hands on a roll. Move hands at different speed. Move one hand at a different angle. What happens? See the spin? You don't see that spin. It's happening. Here comes your thunderstorm with this nice strong updraft. Starts to tilt it. As it tilts, it's stretched out through the updraft. Narrowed, figure skater bringing the hands in, speeds up, and you get your tornado. There's your tilted updraft. Looks like a UFO kind of. That whole thing's spinning. You can see the striations in it. Right here's your heavy rain core. There's going to be a tornado. It's dropping right there, right at the base of the updraft, right at the base of your wall cloud. Here now is your typical northern Michigan, or Michigan in general, tornado. Got to look hard. There'll be some clues here. Tornadoes, they're like vacuums. They're sucking up stuff. Leaves and trees. So watch what you start seeing fall here. I think you can see right here, there's some. Here's some more. And there's your spin. So look at the leaves fall out of the sky. And you'll see it really good here in a second. Look, it's like rain and leaves. Quick hitting, not those majestic things you see on the news tonight or the Weather Channel that look like this beautiful cone on the ground. This is what we get. Very hard to see, a lot of leaves. What do we have that the planes don't have? A lot of what? Trees. They're often hidden behind trees and they don't last very long. Sometimes 100 yards, less than that, they hit the ground and they're gone. Very hard to forecast. Very hard for us to figure out a lot of times where they're going to specifically be because there's such hard, quick hitting features. Like I said, they're not like the planes where they can go on for miles and miles. That's your typical northern Michigan tornado. Okay, quiz time, and I think there's going to be surprises here. What's our first prize?
What's our first prize? How about a water bottle?
A water bottle. Okay, here we go. I gotta have her hand raised on this one. Most of the thunderstorm wind damage in northern Michigan is a result of which type of thunderstorm? Think squall lines.
Multi-cell.
There it is.
Water bottle for you.
Water bottle.
All right, congratulations.
Thank you, Jim. Oh,
Look at that.
Oh, here we go. Think about your horizontal spin. What's going to tilt it? So you got the horizontal spin created by wind shear, but what tilts the wind shear into the vertical? Yes,
Now this one is not a this is a bird bell feeding bell for your birds.
What we got? There we go, updraft.
Congratulations, the birds will be happy.
Great job, great job. Okay, here we go. Now, we looked at tornadoes, we talked about winds, but you know what? Thunderstorms bring a lot of others. Hail, lightning, flooding. Flooding. The #1 storm-related killer that we have in the U.S. besides heat-related deaths. That's it. Flooding kills a lot of people every year. Large hail. Does that look like Pizza Hut? We got Pizza Hut up here. We have Pizza Hut, don't we?
Yeah.
Yeah?
A little hat does look
Little
like
hat, it does. Large hail. Simply put, the stronger the updraft, think about the wind blowing straight up in the air. Okay? It's going to suspend a lot of stuff up there. The longer it can suspend it and grab it and keep it up there, the bigger your chance for hail. Hail forms, of course, above the freezing level where it's cold. Like I said, in the summer, there's no seasons up here. It's bitter cold. Okay? So you got hail forming up here, rain that's freezing, forming ice balls. What did I say about overshooting top? Here's your lid, here's your stratosphere, here's your anvil. This should be the normal lid, but look at your updraft breaking right through it. It's that strong. It's breaking your lid. It's knocking the lid off your pot of boiling water because it's so strong. So when you see an overshooting top, you got a strong updraft. Strong updraft does what? Makes the hail what? Larger. Here you go. Marquette. The UP. That's baseball, golf ball, destroying trees, damaging cars, $60 million in damage. Upper Michigan. It can happen. Here's some other pictures of that. Look at the amount of hail collected. You know, you could plow that. Look at all the leaves. Look at the house here, the siding from the wind blowing that hail into the side of the house. And I can only imagine what cars must look like. Hail safety, just common sense, get inside. Don't go outside during a hailstorm. If you're outside, get in. If you're stuck in a car trying to find some structure to take shelter, gas station canopies are great. Get your car inside. If stuck outside, seek shelter under a sturdy overhang. Just common sense. And finally, You know, with the great warnings me and Jim will give you, you'll have plenty of time to move all valuable objects inside to avoid damage. You can count on that. Look at some of that hail right there. That's 2 inches in Wexford County. Don't do this. Want to protect your spot. Why? Now you can see obviously that's not from around here. Okay.
He didn't have insurance on the car, he was trying to save it.
Yeah, we do not recommend that. That's not one of our best practices for hail. Lightning. By definition, a thunderstorm must have lightning. When you hear thunder, what do you think produces thunder? I'll give you a hint. Yeah, lightning. Lightning is hotter than the surface of the sun. It's over 5,000 degrees Fahrenheit. It warms the air so violently, it sends out a shock wave that your ears pick up as thunder. Okay? So if you heard thunder, I don't care if you've seen it or not, there was lightning. Now I get questions like, what about heat lightning? I see lightning, I don't hear thunder. Well, thunder can only travel about, on a good day, 10, 18 miles, something like 10, 20 miles. So heat lightning could be lightning that's so far away at night, you see it at night, it's way out in the distance, it's producing all kinds of thunder, it's just not making it to your ears. Look at that slow motion, do that again there. You can see here, right here, there'll be a leader coming down, barely visible. It makes the connection with the ground, bam. Okay? Rub your foot on the ground, go touch a door handle. You get shocked, don't you? Much bigger scale. Okay, up here in the cloud, you got rain, hail, everything, bumping off each other. You got that updraft, all kinds of wind, and that's all that stuff doing this. Okay? Mother Nature doesn't like to be out of balance. That's what weather does. Weather tries to make everything in balance. Hates anything out of balance. That's why you get weather. Why you get lightning. One charge in the cloud, the other charge on the ground. Opposites what? Attract. Mother Nature says, well, you know, if my charge is too big here, I gotta do something. The charge difference, and it makes lightning. I love severe weather. As a meteorologist, we do. Ain't gonna lie to you. We don't like high pressure. That's kind of boring. Go to work and sit there and do nothing, okay? We like severe weather. I love thunderstorms. The only thing that scares me in thunderstorms this day is lightning. You know why? Because I can't tell you where lightning's gonna hit. There is no way I can tell you anything I look at where lightning's gonna hit. I know it wants to find the tallest object. Wants to find the quickest way to get rid of that charge. Is it always gonna hit the tallest object? No, but it likes to find the tallest object. This second bullet here, Michigan, we see it on the map, doesn't get a whole lot of thunderstorms. Gets quite a few, but you know what? We're always pretty high up there on lightning fatalities, lightning injuries. Lightning likes to find the tallest object. What are we surrounded by that if you're on, you're the tallest object? Right out the door here. We're surrounded by, water, the Great Lakes. You're on a boat, you're the tallest object. Last year, I come to do radar duties. We had some thunderstorms popping up. I sat down with the radar and made a comment to the guy, the lead forecaster. I said, you know what? It's amazing. We can pull up lightning displays at work. We can see, where the bolt. We can't see where the bolts are, but we can see where the storms are producing lightning. And I made the comment, hey, these thunderstorms are hardly producing any lightning. It's pretty unique. There's a few out there. I don't get a lot of bolts. It wasn't 5 minutes later, I got a call with 2 ladies that were killed in the Osable River. Just getting out of their boat, or getting out of their canoes, but not quite in time. Just minutes after I said that. Last spotter talk I gave, down in Alcona County, a lady come up to me and said her grandmother was killed washing dishes from lightning that went through the window. Had the window open, the screen open, went right through the screen, hit her as she was doing dishes. Void water, all metal objects, electrical appliances. Cars are great. The lightning will be dispersed around the car. Tall objects such as trees, towers, poles, fences. Every year you hear about people, it starts raining, they don't want to get wet, they go under a tree. Lightning hits a tree, it's dispersed in the ground. Can hurt a lot of people that way in a quick way. And there's your lightning strike on May 15th in Missaukee County. Extremely powerful. Lightning victims do not carry a charge. If you ever come across one, you can start producing or start doing CPR right away. They do not carry a charge.
Good question, Mike.
Yes,
Our nephew was on a golf course and
golfing.
the foursome was hit by lightning, and when they came to, they were laying on the ground. My nephew had little bumps all over his arms. The tallest man in the group was killed.
It probably hit him first. Probably went through. And like, besides water, Michigan, especially where we live, is famous for golfing. And when you're on an open fairway, you know, you're not only one of the tallest objects, you're carrying a club. So yes, unfortunately, it happens all the time. Like I said, I can tell you there's a thunderstorm there, but I can't tell you lightning's going to hit that golf course. We just don't have that capability. Here we go. Number one killer besides heat in the United States, flooding. Why? People are just do dumb things. Case in point. Okay? I've done this. I've drove through floodwaters. I ain't gonna lie to you. I drove on a road many times. Said, hey, that water ain't deep. I know all what that water, that's a couple inches. Well, there could be some issues. That road might not be there, and I think I'll show you a picture. I think there's a picture coming up to show you that. Look at these people driving through floodwaters. 1 foot of water can move 1,500 pounds. Anyone here trout fishermen go wading in rivers? There's a lot of force with water. It don't take a lot to knock you off your feet. Most flooding and deaths occur in cars. Bad decisions. Common sense with flood safety. Never drive, walk, or swim in floodwaters or rising waters. Kids especially, every year we get a report of kids dying because they go out to play in the flooding and they get sucked down ditches, ravines, and culverts. It's terrible, but it happens every year. Turn around, don't drown. You've heard that slogan if you encounter floodwaters. Go the other way, seek higher ground. 6 inches of water will knock you off your feet. 2 feet of water will move a 3,000-pound vehicle. And guess what? When your vehicle is suspended in water, you can turn it all you want. You're out of control. Water does whatever it wants to you. Case in point, this guy here, can't figure out why his car won't start. You know, this is what we see. People just driving through floodwater singing, hey, my car can make it. It doesn't take much. And once you're stuck, you're on your own. Water spouts. We've seen them here. Anyone seen water spouts? Yeah, like I said, 2 types. The most common that most people have seen non-tornadic. Every fall, September, Leelanau County. Early winter, you get non-tornadic water spouts. Extremely common. They're caused from the initial stages of cold air. The fall's coming in, got cold air coming out of Canada. The lakes are extremely warm. They're at their warmest point. Instability. You get these shallow showers. And you get enough spin out there to produce these water spouts. Generally weak. Winds of 50 miles an hour, maybe more. They generally do not make landfall. They can be hazards for boaters. If we see them on radar, we have an idea on radar. They're hard to see because they're so shallow. Or we get a report from a mariner. It is our responsibility to issue a special marine warning because they can do some damage to small boats. And if they do make it on shore, we have to issue a tornado warning. It is a tornado. The big ones, though, are the tornadic ones. That's nothing more than the tornado forming here and going over Whitefish Bay. Much different beast. These are generally much weaker and extremely common. And you can see non-tornadic associated with thunderstorm, or not associated with thunderstorms, are typically in the early fall or early fall through early winter. Rip currents. You know, people think these are the Atlantic coast thread, the Pacific. Look at Michigan in the Great Lakes, 10 drownings per year. This is a key thing we're really focusing in on. All the weather offices, a lot of people are getting together. Is this unacceptable? Problem is, rip currents happen all the time. All that water being blown in from the wind and waves hits the shore. It's got to go somewhere. Okay? It goes back out. It finds a weakness in these sandbars. It's a jet. You're swimming. You look up. You're having a good time. And all of a sudden you're like, oh my Lord, I'm 100 yards offshore. You panic. What do? I want to get to shore. I'm swimming. Well, you're not going to beat the rip current. You're in the rip current. Go parallel to shore. These are usually small, 10 yards or less. And then the winds and waves will help bring you in. Like I said, 10 drownings is a lot in Gulf. We're issuing statements on these now. I know beaches are being very proactive and putting up some caution signs to inform this might be a rip current day. And one of the deadliest spots in the Great Lakes, like I said, is US 2, just outside of St. Ignace. I've swum there before. Those are the most beautiful beaches I've ever seen. But that's very common there. And that's it for my portion. We're gonna have a little show here. It's called damage assessment. Whenever we believe there's a tornado, it's our responsibility to go out and do a damage survey, and we're gonna explain that here a little bit and the difference between tornadoes and straight line winds. And we got cookies, thanks to Mr. Tim McKee, and coffee, and a whole bunch of other stuff up there. So
Yeah, we'll start up about 5 minutes. This will run about 5 minutes, but get a leg stretch, get some food, and we'll start up again.
and more importantly, Scott,
$1 million Doppler radar. We have lots of computers. We have computer simulations, computer modeling, all sorts of information like that. With all that information, why in the world do we need spotters? I mean, isn't the technology enough that we wouldn't need spotters? The honest answer is we have one problem that we have yet to overcome, and the big one is curvature of the Earth. You know, when we send a pulse of energy out from our radar, it goes out in a straight line. But of course, the Earth isn't flat, and so the further that pulse of energy goes from the radar, the higher it's sampling over time, and it becomes higher and higher and higher. And so by the time, for example, we get to Sault Ste. Marie, and we're looking from our Doppler in Gaylord, we're missing the bottom several thousand feet of the atmosphere we can't see. We can't see. Now, the answer to be, and this is all across the country that this occurs. Now, of course, you'd say, well, just put in more radars. At $15 million a radar, that's just not going to happen. There's just not going to be, you know, you're not going to have, because we could use a radar on Beaver Island, we could use a radar in Sault Ste. Marie, we could use a radar. There's a lot of other places where you'd love to have more radars. It's just not going to happen. So the Doppler radar is a great tool, but the ground truth information is critical. The Doppler radar can tell us the potential of something happening, but it doesn't actually tell us if it's occurring. We can see rotation on the radar. Does that mean that there is a tornado, even though it's saying it's the potential's there? Well, not always. We may say it has the potential to produce large hail. The radar may say that. Is it producing large hail? We don't know. So the best warning is one in which we take something we're seeing with the technology, but we're combining it with ground truth. And we put those two together, it's really the best possible warning we can put out. The most difficult time for a forecaster sitting on the radar, and I think Mike can attest to this too, is when you don't get any phone calls or any information about what's happening. Very difficult, because what happens is we'll put out a warning. No reports. Nothing comes in. Storm looks bad on radar. Storm still looks bad on radar. Warning is going to expire. No reports. Well, still looks bad. I'll put another warning out. No reports. No reports. After a while, do you think the person on the radar starts to question whether they should keep putting the warnings out? Sure. It looks bad, but we're not getting any reports. Reports are critical. They're critical to the confidence of what the person sitting at the radar is. It is critical to the warning process. So any time of day, we're there 24 hours a day. Any time of day, if you've got something interesting weather-wise, don't ever hesitate to call us and let us know. We never have too much information. That's never been a problem, so I don't think it's going to be a problem in the future. We're always willing to accept more information. Okay, severe weather definitions. These have been around a long time, but we'll review them. A watch. Watches are issued for large areas, usually portions of a state or even multiple states, usually for 4, 6, 8-hour periods. All it means is that conditions are favorable. The ingredients are there for something to happen. These actually originate from the Storm Prediction Center, Norman, Oklahoma. They sort of collaborate with the local weather service offices, and that's where these watches come out. And they're just basically there as a heads up to say, you know what, we're not guaranteeing something's going to happen, but you've got a lot of ingredients in play where the atmosphere is primed and ready to go. Now when it gets to a warning stage, that means usually, you know, we're issuing those for a portion of a county. A lot of times 45 minutes, no more than an hour. And it means either we've seen something on radar or we've gotten a report of something from a spotter. So it's either occurring or imminent. I know that's hard to read. Severe weather is occurring or imminent, take action now. That's what that means. What about criteria? Well, obviously any thunderstorm that produces a tornado would be severe. Winds greater than or equal to 58 miles per hour. Why 58 miles per hour? Seems like a rather interesting number to pick. You know, why not 62 or why not 55? Why 58? Well, a lot of these numbers originated many, many years ago, and they were agriculturally based. They were based upon thresholds of damage, and many times in an agricultural context.
Crop damage.
Yep. Now, whether 58 is some magical number, I don't think it is. But you had to pick some number, you had to make a threshold somewhere, and 58 was going to be that number. Now the hail used to be 3/4 of an inch, used to be the criteria. A couple of years ago, that number was changed to 1 inch. Now I'll give you a question. You're at your house, thunderstorm comes overhead, and the thunderstorm produces 6 inches of pea-sized hail at your house. Enough that they're bringing out the snowplows to remove it off the roads. Did you have a severe thunderstorm at your house? No.
Not quite like that.
Pea-sized hail, less than an inch? Nope. You're at your house, thunderstorm goes overhead, 1 inch hailstone falls on your deck railing. Did you have a severe thunderstorm? Yep. Now, that's obviously a little bit of the dramatic as far as it's not going to happen like that, but it is not the quantity of the hail. It doesn't make a difference how much hail falls. It's just based solely on the size of the hail, completely. So, now if you actually study hail, you'll find that in any given event, you have hail all different sizes a lot of times occurring. And so you might have one inch hailstone and a lot of smaller hailstones. And that's more common the way it occurs. It's not all the same size a lot of times.
Need a micrometer.
Yes,
Need a micrometer to measure them.
absolutely. You can use a micrometer, absolutely. Or you can use the back of your spotter card, which has a hail measuring little ruler on it. This is a simpler definition if you remember nothing else about the talk tonight. Watch means conditions, something could happen. Doesn't mean it is happening, it could. Warning, get moving. Take action. Okay, new this year. Based on the Joplin tornado of last year. Remember Joplin, devastating tornado occurred. And what they found was, in looking at Joplin, was that they had plenty of lead time for the warning. That was actually a quite easy storm to warn on. Huge storm. Very easy on radar to warn on those. But some people didn't take action. And when they asked the people, why didn't you take action? They said, well, we didn't realize that the tornado was as bad, like it wasn't just a run-of-the-mill tornado. Because we get a lot of tornado warnings in Missouri. We thought it was just a run-of-the-mill one. We didn't realize it was catastrophic. And they said, oh, well, maybe we need to rethink what we're doing a little bit to indicate that not all tornado warnings are created equal. And so what they're doing, and this mainly impacts areas that receive a lot of tornadoes. You're not going to see as much impact here in our area, but it is something to be aware of, is that they're adding a tag, a little tag area right here, tag line, to the bottom of every warning that gets issued by the Weather Service. And in that tag line, first of all, it's going to tell you based upon what kind of damage is expected from a tornado. And you can see that if it was Joplin, you're not going to see these here in northern Michigan. But if it was that type of tornado, you're going to see a tagline down there that indicates that, you know what, this isn't a run-of-the-mill tornado. This is something catastrophic, much beyond the run-of-the-mill. Now, what about for northern Michigan? What would we see different up here? Well, one is this. That tagline, if there is a tornado warning, is going to tell you whether it's radar indicated or whether we actually have an observation from somebody who saw it. Might be interesting. I mean, you still should take the same precautions if you get the warning, but they've determined that people act more aggressively as far as taking action when they find out that something's been observed versus something it's just radar indicated. Another thing that you could possibly see is that What if we have a severe thunderstorm warning that shows some rotation, but we have low confidence of it actually producing a tornado? But we don't want to say 0 chance. Well, now there's actually an option to say, you know what? This is a severe thunderstorm warning. We have low confidence, but you know what? We're seeing just enough on radar that we're going to throw in tornado possible on that tagline. So for the most part in northern Michigan, because we don't receive lots of severe weather like they do in the plains and the big tornadoes, we're not going to notice extreme differences here. But if you travel to other parts of the country that certainly are more tornado prone, with bigger tornadoes, this is something you'd want to be aware of too, to see some of that language as far as catastrophic, considerable damage, things like that you'll see in the bottom of the warnings. Any questions about this? This went into effect April 1st across much of the United States.
This is experimental.
It is experimental. It is technically still being tested. Last year it was tested in a handful of offices. This year they expanded it to much of the central portion of the United States, including Michigan. And I think after this year, they're hoping if the test goes well and they're receiving feedback on it, they'll probably tweak it a little bit. It may be expanded and made official, but this is sort of how things roll out. In the government, this is how things roll out. You have to go through a year or two of experimental phase. You have to get public feedback. You've got to go through 12 different committees, and this is just sort of the process. And then eventually, it gets to the point where it becomes an official product, and that's it. So, okay, spotters need to stay informed. And boy, this is an ever-growing list, it seems like, because technology is really changing how this happens now. I mean, to think about, when I first came in the National Weather Service, we were doing basically the slideshows we were doing were the old, remember the old circular slides where you had a little what was that? I guess I'm searching for the words of what that was all.
Carousel.
Carousel, yeah, the old carousel slide. That's how the spotter talks were occurring. That was it. We've gone from that 20 years ago to now the amount of information, weather information that people receive, because this was, once the internet came and came into use, and everyone has a computer and everyone has a smartphone, and everyone, it's amazing now. Social media has changed that. We'll talk a little bit about that. But the constant communication that goes on now is so different than it used to be. So spotters need to stay informed. I always like to say that you will find most everything you need off of our website. And has everyone here been to our website? Weather Service, weather.gov/Gaylord. This website right here, radar information, obviously all the watch and warning information, climate information. You want to know the seasonal snowfall totals. You want to know where you are compared to normal. You want to know river levels. You want to know, you name it, it's available on that website. There's actually probably too much information on that website, but there's a lot of information on the website. We'll also talk about some of these other things, houses, weather briefings, weather radio, Facebook, Twitter, media outlets, lots of different ways that people are getting their weather information now. This is something a little bit unique to our office. It's not being done at many other offices. Twice a day, every single day, about 5 a.m. and 5 p.m., after the forecasters complete their forecast package basically for that day, they're what they think the forecast is going to be, they go in and create about a 3-minute video with slides talking about the expected weather hazards over the next week for northern Michigan. That's available to you every single day, twice a day updated. If you go to, this is the long address right here, but actually if you just go to our webpage, you can find it. This is right at the homepage at the bottom, right here under Expert Weather Briefing. You'll find it right there. And then you can bookmark it. The link doesn't change. So you can get that. You can get that on your phone or wherever you want to pull it. You have internet access. Weather radio. Anybody weather radio users here? Anybody with weather radios in the crowd? Okay. Handful of weather radio. Weather radio is trying to, in some ways, sort of find a niche with all the new technology to some degree, because it's, you could argue it's being crowded out by a lot of new technology. But I think it still serves a role, much like the smoke detector in your home serves a role that your smartphone hasn't taken over for. Your smartphone's not a smoke detector. And at 3 in the morning, if the tornado's bearing down on your house, the weather radio can wake you up. Most other things that people depend on, like their television or commercial radio station or other things like that, don't. Also, if you're an outdoors person, if you're a boater, hiking, fishing, whatever, weather radio still serves a purpose as far as having that device and getting warning information to you where you need it, even in remote areas. Sometimes you don't have cell coverage, but you might have weather radio coverage. So it's an inexpensive device, about $30 for a weather radio at an electronics store, online. And I still think makes a great gift as well. You know, a great Christmas gift, Father's Day, Mother's Day, you name it. Still makes a good gift and a practical gift. Housewarming gift, great housewarming gift. I'll give you ideas. I don't get any commissions on this, but these are good ideas for weather radios. Okay, the number one priority is stay safe. That is the biggest thing, and you need to develop a plan before the weather strikes. So for example, if you live in a mobile home, the time to consider what your action would be if a tornado warning is issued would not be after the warning is issued. You should have that plan in place right now. Because the average lead time in a tornado warning is about 9 minutes. And that's if things are going well. 9 minutes is not a very long time to develop your plan at that point. So you should have the plan now. Figure out what you're going to do. Are you going to stay in the mobile home? Do you have another spot close by? You know, they're even making some things, I know in tornado country, with the steps in the mobile homes, there's actually storm shelters within that area that you climb the steps, you can actually get inside that, and it's actually reconstructed, anchored down like a little mini storm shelter right there that people in mobile homes get out of their mobile homes and go into this little shelter where their stairs are. So there's a lot of neat sort of new ideas coming about that are for safety purposes. Okay. Ideally, and this is one of the most difficult things that a spotter has to do, if you give us weather information, we would love to get an estimation of what the winds are. Very, very difficult to do. On your spotter card, there's a little small version of this scale right here. This is a Beaufort scale, and this scale is from the 1800s. Sir Admiral Beaufort developed this for marine purposes in the 1800s. And they liked the scale so much, they adapted it for land areas as well. You can tell it's an old scale because we don't have a lot of slate on roofs anymore. Things like that indicate, but the relationships are still true. Now, why is wind estimation difficult? And why is it full of error? Because what is really the only thing you have generally to make a wind estimate if you're a spotter? Trees. Trees. Trees are notoriously a bad way to make a wind estimate. Why? Well, because there's so many variables within the tree. What type of tree? How old is the tree? How healthy is the tree? What kind of exposure does the tree have versus with other trees? All those things play into it. And so not all tree observations are created the same. The point is, if you could even tell us what you're observing, that helps us. Even if you don't know a number, and you could just say, you know what? I had a couple of such and such size branches that came off in my yard. The trees are halfway down, bent over, and you know, whatever. My bird feeder just went into my swimming pool. I don't know. Whatever you're observing helps us to indicate, because we can make a judgment then on what the winds are to some degree just by telling us what you're seeing at the time. For marine spotters, anybody here live sort of on the Great Lakes or right, you know, in close proximity with a view to the water close by? No? A little bit?
Next month.
Yeah. Well, if possible, you know, we love to get wind and wave observations as well. So, because we can use that information to sort of tell us if what we're forecasting is accurate. We sometimes don't know what the wave heights and things are. You know, we have buoys, but there's only a couple of them. And, you know, so if you call in and say, boy, I've got 8-foot waves right here I'm observing, and our forecast has 3 to 5, we can change that. So that it helps us to have that information. Hail size estimation. First thing is, do not go outside during a hailstorm. Seems obvious, people still do it. Do not protect your vehicle, it's not worth it, just like the gentleman was trying to do. Measure it as soon as possible after the storm, and you can use a hail card, a ruler, a caliper, or something like that. You can really use whatever you'd like. Ideally, either give us an exact number or with relation to coins, because we all agree on the coin sizes. Don't use something like small marble. because marbles come in all different sizes. But if you say it's dime size, I know what size that is. If you really want to mess with maybe one of the new workers at the office who might be answering the phone, you could give them a size like a Susan B. Anthony coin or something, and they probably would have no clue what you're talking about. One of the new guys, be like, Susan B. Anthony, what's a Susan B. Anthony quarter, or whatever. How big was the Susan B. Anthony? You remember? How big was it compared to a quarter? Was it bigger? Was it a little bigger than a quarter? Was it? I don't know. I haven't seen a Susan B. Anthony in a long time. Or a Sacagawea, what was it? Sacagawea dollar?
Yeah.
A dollar, yeah. So. Okay, how about a review of some important storm clues? And Mike did a great job, and these are just going through. Obviously, the overshooting top, that's where that strong updraft punches through the lid, goes up into the stratosphere, indicative of, obviously, a well-developed thunderstorm. It's going to produce and keep that hail aloft longer. You're likely to see large hail in a thunderstorm that's got an overshooting top on it. Here's a shelf cloud. That's the leading edge of cold air outflow from that thunderstorm, pushing out away from that storm. Obviously, it looks like the snowplow, putting warm air in front of it to rise. All the weather is behind it. So here it is right here. Here's your shelf. Notice all the gray, all the weather behind it, and watch what happens right as this passes in this time lapse. Notice all the wind and everything is behind that shelf cloud. So you're going to get a wind direction change, you're going to get a wind speed change, and you're going to get all the weather associated with it, hail, rain, and everything else after that cloud passes you. These are the supercell features. We've got this white, brighter area, which you likely will rarely see in Michigan, because this is sort of the classic supercell textbook that you see in the plains. Because of trees and a lot more rain here, you a lot of times do not see the classic look to the storms like you do in other parts of the country. But obviously this bright white area here, that's where the storm is ingesting that warm air. That's where the updraft, basically, that warm air is being ingested. You've got your updraft basically holding everything above you at that point, so there's nothing occurring at that point other than you've got your isolated lowering of that rain-free base, and that's your wall cloud. Your tornado would come out of that. Here's your rain area associated with your downdraft.
Is your tornado almost always going to come out when it looks like that? Or is that just if there was going to be a tornado, that's where it would
If
come?
there's going to be a tornado.
Okay.
Yeah. Like Mike said, a large majority, 99% of these don't produce tornadoes. So, so that's something, it's really the challenge of tornado forecasting and trying to pinpoint it, is that just because we see a supercell doesn't mean we're actually going to see a tornado from it. And that's where spotters come in. They can help us a lot by giving us ground truth of what you're observing. Okay, a few other common clouds and features. This right here, you'll see this quite a bit. You'll see this in any time of the year, and that's Virga. What's going on there? Well, that's just precipitation falling out of a cloud. The air beneath the cloud is relatively dry, and so you're evaporating that precipitation before it comes to the ground. So really nothing reaches the ground, but you're seeing it in the distance. You can see it with snow, you can see it with rain. Sometimes though, if you just take a very quick look, it can be deceiving, because it can sometimes take the shape of something that looks more ominous than it really is. This is mammatus, and these are made for great photography. What you're looking at with mammatus, these are like pouches underneath the cloud. It's really the underbelly. It's the underside of the anvil, that area that sort of flattens out as it reaches the more stable part of the stratosphere at that point, flattens out at the top. The underside of it, you get these pouches. And by themselves, mammatus really doesn't produce much of anything. You can still get lightning, but a lot of times, storms that have mammatus, at one point in their life of the storm, it was a larger, more well-developed storm at that point, and was probably producing something. But generally, they're more for photography a lot of times now than anything else for mammatus. The last one here, boy, if there's a cloud that causes more trouble with tornado reports and false tornado reports, it would be that one, and it is Scud. What is Scud? Scud is basically a garbage cloud. It's a cloud. It's a low, dark cloud. A lot of times, multiple large, dark clouds. A lot of times, sort of toward the tail end, after a rain event or whatever, you'll see a lot of this straggly, fragmented stuff around. And the problem with Scud is if you take rather quick look and you don't spend any time observing it, is that it can look very, very bad. Here's an example right here. If you just took this still picture right here, would this scare you if you saw this in the distance? Absolutely. You would think you got a large tornado bearing down on a residential area. But if you watch this, if we could put this in motion, there's a couple things about Scud that would indicate that you don't need to worry. One is it's not attached to the main cloud. If it's a tornado, it's got to be attached. It's got to be attached to the parent cloud. If it's not attached, there's nothing to worry about. It's just a fragment. It's just a piece of cloud. The other thing is it doesn't rotate. There's no rotation with it. Which is why before you make a report, especially of something like a tornado, give it a second. Just be a little bit patient and just wait to watch, just to make sure what you're seeing is in fact that you've got rotation or that it's actually attached to the main cloud. Okay, oh, we've got a quiz question, and Mike, we've got prizes.
What are we giving out now?
You know what? I think we've got one big prize.
We
now,
do.
Right? Now, how about let's save the big prize.
Oh, the big prize.
Yeah, save the big prize. And let's just go with a couple more water bottles.
Okay.
Because we've got water bottles. Want everyone to leave with a water bottle tonight. Okay, which of the following is not a criteria for a severe thunderstorm? Raise your hand if you know the answer, and you can win the water bottle. Which of the following is not...
Tiger hat back there, tiger hat.
You want the Tiger fan?
Tiger hat.
Okay, even as a Yankee fan, I'm going to call him the Tiger fan.
Hey.
Hey.
Oh, look at that.
Look at that. And
58.
what is the criteria?
58.
58. Excellent.
Wow, good job.
Would you like 2 water bottles because you said 58? Because we have extra. Want another one?
Yeah, why not?
Okay. Okay, more opportunities, more opportunities. Which cloud feature tells you about the potential for a thunderstorm to produce large hail? Show of hands, don't want to blurt it out here because we don't want to. What do you got?
I'm probably gonna guess right now, C?
Overshooting top?
Wow.
Looks like good. Yeah.
Thank you.
You want 2?
No, one's fine.
One's fine? You sure?
Maybe I'll guess again.
Okay, now I think we'll use this last one.
For the big prize?
I think for the big prize.
Big prize.
Because this is a 3-part question. And I think the 3-part question.
First of all,
Let's show them what the big prize
we
is.
gotta show your own personal
Little rain gauge. Yes, that's the big prize of the night.
Yeah.
B.
Okay, hold on. Okay,
Oh, this is tough.
now you have to, this is a 3-part question. You have to identify 1, 2, and 3 in the picture by, anyone wants to raise their hand, even if you've already won a gift, you can win again. Okay, we're opening it up to whoever wants to try to give us the 3 parts here. Need some Jeopardy music for this. Who's going to win the rain gauge? Anybody want to venture a guess? Somebody? Look at your notes.
Maybe you can just, well, they can name it or.
Yeah, you can even be close. I mean,
Yeah.
you can just tell us what's happening even. You
Yeah.
can give us the exact name. You can tell us what's happening in each one of those numbers. Somebody want to try? Nothing ventured, nothing gained. You know, it's the... You have nothing to lose by trying. We have somebody who wants to try. Okay, what do you...
Three's where it's coming down, 2 is where,
What's coming down?
downdraft,
Downdraft? Yeah.
moisture, what that.
Yeah, rain, yeah.
1 is the center where could be rotation in there, and that's where the tornado comes from.
1 or
2,
Two,
excuse me.
Two, yeah,
And
yeah.
then 1 is updraft going up.
wow, rain-free. Oh.
Yeah, you get your rain-free base. It's in
He is on fire, people.
Wall cloud, rain area. Yep, there you go. Big winner of the day right there. Yeah, water bottle and a rain gauge. Okay, so if you're going to give us information, what should your complete report include? Use the TEL method. Time, event, location. When did it happen? What did you observe, ideally with a wind estimate? Any size hail, cloud features, flooding, damage, anything like that. And location. The more specific on location you can be, the more helpful it is to us, because if it's a severe weather report, we have to take your report and we have to put a latitude and longitude on our report that we fill out, local storm report, for wherever that location is. So if you have that, if you have a smartphone and you have that latitude and longitude, please provide that when you call us. But if you don't, a road intersection or something, so that at least we can go into Google or whatever and find the latitude and longitude close to where you are. Okay, how can you contact us? Oh, about 6 different ways now you can contact us. We'll talk about the 800 number and some social media and internet report forms. 800 number. This is an oldie but a goodie. It's been around forever and it still is valid 24 hours a day. If you want to call us with a weather report, you can do so. And we will be happy to take that information, whatever you have. If you have like a tornado bearing down on your house, we would recommend you always call us and do not use something like the internet to relay that information. Always call us and make sure we get the right information on something big like that. That 800 number is on your card, and ideally don't, that's sort of it's a weather reporting number only. So if you call that number and you aren't reporting weather, we'll likely, in a nice way, tell you that it's, this is sort of our 911 reporting line almost. We appreciate the information. If you're looking for just, the weather forecast for your vacation, that's not the number to use. There's actually a public number that we can provide if you're just looking for generic weather information. That's just for weather reporting. Facebook. Any Facebook users in the group here? A few? How many of you have liked our office page?
Well, there we go.
All right.
Wow.
If you haven't, we're always looking for more likes on the page.
Jim, is that worth it?
Yeah, that's right. If you've liked our page and
Yeah.
you'd like a white water bottle, we can hand it out.
That's gotta be worth something.
Hand up. Yeah, she wants to give. Yes, there you go. Okay. If you haven't looked at what we do on Facebook, though, we're on Facebook 24 hours a day, and although we sort of joke about it, it is a great way to have sort of a more personal communication with a forecaster 24 hours a day. So if you have a picture, if you have weather information, this is winter or summer. You can tell us what's going on any time of the year. This is a winter report we received, and you can see that we received the report. A lot of times we'll respond, like, thank you, something like that. We'll get that response, usually, something like that. And then, here's that local storm report. When I said we had to fill out a local storm report, we have to do this when we get a certain criteria of report. And so, we have to put that latitude and longitude with that report. And so your information, whether it be via Facebook or other places, is going to go out in an official report in that case. So Facebook is a great way to communicate. We put interesting little weather tidbits on there and stuff too every day.
I like the satellite pictures.
See,
Yeah.
They're beautiful.
See, so we put interesting things that nobody else can see. We put them on our Facebook page. So I'm giving you reason to go to our Facebook page and check us out. Okay, I do not tweet. Does anybody here use Twitter? I don't use Twitter either. This is becoming larger though, and certainly in other parts of the country, this is becoming very, very large. I'm guessing it will become bigger here in northern Michigan over time. But if you do, we monitor a number of Twitter feeds as well. And especially for younger people, I think now, the college kids and all, boy, it's all Twitter now. It's all, Facebook's almost old school. Everything's tweeting. Everything's tweet. You gotta tweet everything. So we monitor and we have hashtags, and since nobody here uses it, I'm not gonna spend a lot of time on Twitter. So, unless you have a question, and then I probably won't be able to answer it anyway, because I don't tweet.
Is there going to be a test on it?
There's no test on Twitter. There's no test on Twitter. We have a YouTube channel as well. Now this presentation will also be on the YouTube, but we have a YouTube channel, and on that YouTube channel, we have put up there some videos of like a virtual office tour. You can see a balloon launch, you can see some of the things inside of our building, you can see the inside of the radar, things like that. That's on the YouTube channel. So if you go to YouTube and go like National Weather Service Gaylord, you'll come to our page. We also, every time we do one of those expert weather briefings, it posts to the YouTube page as well. So you can get the most recent one of those briefings as well on that page. So check out the YouTube page for us. And that's not enough. We now have a basic internet report form that doesn't require you to register or give us basically almost no information at all. If you're just don't want to provide information to, you just say, I want to give you information, but I don't want to put down lots of information about myself. Some people don't want to do that. There's a report form. On our webpage, it says send weather report, and this is what it is right here. And you don't have to provide, you don't have to register. You basically can just provide weather information to us. The other neat thing about this is that if you ever experience, like if you notice like there's a weather radio problem, something like that, you can fill that bubble in and give us a little information to let us know that there's a weather radio issue that we need to take a look at as well. And that gets alarmed right into our workstations at the office. So another way that you can get a hold of us. I mentioned this before, we need your reports. Don't ever assume that we have the information, because I think a lot of times a lot of people assume that, and then nobody calls or nobody gives us the information because they don't want to say that, I don't want to bug you. You're not going to bug us. We never have too much information. Kokoraz, yes?
With the information, because we live in Kinchlow, I assume the 911 center gives you information. Would that be correct, though?
That would not always be correct.
Oh.
No. Because the 911 centers, we call them sometimes, but depending on what's going on, sometimes they are so overloaded and so busy, they don't have time to relay information to us. In fact, sometimes they don't have time when we call them to get information. They hardly have time to give us information, even if we're calling them.
Okay.
So, yeah, don't make that assumption that if they're busy, if there's a lot of weather, if they got power outages or accidents or other things, they're overloaded and they don't have time to pass information on to us. So, and even if they have, there's really no downside in giving us the report again. We'll always take the information. It's not, there's no negative to getting more information. Kokoraz, anybody here Kokoraz Observer? This is a program, and it's sort of a tangential program to the spotter program as far as Skywarn Spotter. This is a community collaborative rain and hail and snow study. Thousands of observers across the country. It's a free program. All you need is a rain gauge and internet access. It takes about 5 minutes a day. And what you do is you sign up, you get a little training, you go through a little training online at this kokoraz.org. You get a little station ID for your location, for your house. You will become like a little miniature weather reporting station. And then you can put in rain, snow, hail information in there every day. It goes onto the national map. It gets used by all sorts of organizations that use that information that's collected every single day by all these observers. It also keeps track of all your information. So if you do it every day, you'll be able to look and it'll keep track of all your rain and snow totals and all that. And if you did it over years, you'd have a nice database of all that information online into the system here. So if you're interested in weather, or you're interested in getting a kid interested, or a grandkid or something like that, it's a great program. We have schools that are involved with it. We have other organizations, and it's just an easy way. 5 minutes, doesn't take anything to make a measurement and then put it on the computer. Very, very simple. There's some online spotter resources. This is our homepage again, and right here toward the bottom, there's something called Skywarn. If you click on that, there's a couple of things. One is, these are all PDFs. If you ever want anything that's here and additional information as well, something you wanted to print off for your own purposes, all of those are in PDFs on there. These are great courses. Anyone here taken these 2 courses? There's 2 online courses that you can take that go into even more detail than what we talked about tonight, with a lot of the basics, convective basics. I receive a report. If you take the class, I receive a report that says you took it when you complete it. So it's certainly not required, but if you're interested in learning more, or just as a refresher at some point, they're 1 hour each, and they are great classes. I've taken both of them, and they really are interesting, and they're well done. We also put a version of the spotter class that you just took on there as well, without the video, because of bandwidth and other things. We can't really have the video on there, so it's not quite as exciting without the video, but it has a lot of the same information on there. If you have any video or pictures, we'd love to receive those. I use those for training, and we also use those. We'll post them on Facebook pages and things like that. Put them on Facebook, through Twitter. You can even call the office and get an email that you can send them to. We'll give you an email account to send them to, or something like that as well. And you are now a trained National Weather Service spotter. Do you feel sort of different than when you came in an hour and a half ago?
Yeah.
Do you feel more knowledgeable science-wise?
Yeah.
Okay. finish off with one video that has nothing to do with the talk tonight. There's nothing to do with the talk. So, are there any questions? Any questions about anything that we've talked about tonight? Any weather-related questions? When's it going to warm up? I've heard that question several times. And to be the bearer of bad news, not anytime soon. Not in the next 7 to 10 days. It does not look like it. It looks like there will be some additional, possibly snow chances even into next week right now. So it is a slow melt. The slow melt continues. It is a not very nice weather pattern we're in right now for spring, and I'm sorry. and there's some potential for a somewhat significant ice storm, not as much up here, but certainly south of the bridge coming up Thursday and Friday this week. There's some things that are very classic, textbook classic, ice and sleet storm potential for Thursday and Friday. So if you are traveling south toward the end of the week, you'll definitely want to be aware of that because there could be some messy travel.
What about flying? We're flying out Saturday morning.
From?
Kinchlow, but then we have to go into Detroit.
Yeah, I mean, you could probably, yeah, I mean, Detroit's not going to have problems.
Oh, good.
You know, it's going to be in between those two, chances are.
Yeah,
but
that'll be good.
there's some potential if this thing goes just a little further north, you know, we'll have to keep an eye on what happens up here. Right now, I think most of it's going to be south of the bridge. You're right on the northern fringe up here, so,
Yeah.
you know, I think by Saturday, a lot of it'll be over with, so.
It makes you feel any better than the parts of the Dakotas, they're gonna be measuring their snow in feet
Oh
Yep.
my
the next couple
gosh.
days.
Yeah.
So,
It was
So-
85 in Austin today.
Yeah.
don't expect that anytime soon.
Not even in August.
So what's our summer gonna look like
You know, we're
then?
not.
Well, what was that thing you said about
You're
March?
not fighting mosquitoes, and, you know, the other thing about it is that
Dude, do they get-
frequently when we see springs like this, cold springs, at least the
Yeah.
first half, summers end up being relatively warm. So that is the official forecast right now, slightly above normal temperatures for the summer. So I think there's a lot of indications that once we finally do, it's going to be probably one of those where there's really not spring this year, it's more of your winter, and then when it finally does warm, it warms and it's like 70 degrees and you've moved
But
into the
it's
next
only for a
season.
day and you gotta have a picnic real quick.
Yes, that's true.
Hey, Jim,
So-
this gentleman here wanted to explain the great news you said about Marches and the following winters.
Well, that's just, yeah, I don't need to impress people. There is a correlation between cold marches in the United States and rather severe winters the following year. So that doesn't mean that's always holding true, but there is a statistical relationship between a cold March in the United States, which this was a very cold March in the United States, and severe winters the following year.
So if you sell your house up here, you can tell the new buyers it's probably never going to be this bad
That
again.
you could say that, yes.
Well, you know, the honest thing is, I think we've all been spoiled the last couple winters.
Yep.
Yeah.
And this is more,
Really.
This is more normal.
if you ask people who lived up here for a long time, they're like, this is nothing.
Yeah,
Yeah.
You know?
really.
Yeah.
But do you think it's like a weather trend? It goes in years like that? I mean,
Oh,
pretty much?
Yeah, yeah. Personally, I think it's a weather trend.
I
think
do
we're,
too, yeah.
you know, we're mimicking a lot of the 1950s recently
Yeah.
with a lot of East Coast tropical activity and other things that mimic the 50s. And if that's true, if you remember the 60s and the 70s, if this trend holds, and we'll know in the next handful of years whether this trend is holding. The 60s and 70s had a lot of pretty severe winters, which is why a lot of people, when they think of old-fashioned winters, they remember the 60s and the 70s, I think, as their prime time of where their memories sit. You know, actually the 50s had a lot of relatively quiet winters. But, you know, I don't think people remember those as much. They remember those wild, more severe winters of the 60s and 70s. So I think a lot of it is cyclical. I think we're going to see, you know, that come about. I mean, 4 of the last 5 years have had record amounts of snow in the northern hemisphere. There's a lot of things that indicate that it's cyclical, but that's another whole talk and another whole discussion.
We could take all night.
We could take 2 hours on that.
My brother lives over
So
in
thank you all.
Thank you, very good.